Now, yesterday I discussed in the previous lecture 8, I discussed about the resistances and combination of resistances. Now, let us, and also I have given you some across the diameter also I discussed. Now, let us see one or two more examples now. Now, if n wires each of resistance are n wires each of resistance are connected in the shape of a polygon, then resistance between any adjacent corners is, this is question. N wires each of resistance are polygon. Let us say this is one wire, another wire, another wire, another wire, another wire, another wire, another wire. These are all, let us say, n wires. Each of resistance R in the shape of a polygon. Effective any two adjacent, let us take these two as adjacent sides A and B. This is asking the effective resistance between adjacent sides A and B. Now, how many you have taken here? 1, 2, 3, 4, 5, 6, 7, 8. You have taken 1, 2, 3, 4, 5, 6, 7, 8. Now, across AB we require. Therefore, across above AB, how many we have? 1, 2, 3, 4, 5, 6, 7 we have. 7 plus 1 is 8. If you take n resistors means now n minus 1 are the remaining and R is the 1. Let us this like this. Like this. This is R comes about to n minus 1 R. This is another R. This is A. This is B. This is equivalent to, the circuit is equivalent to R, so on so forth to n minus 1 R. How many are there? N minus 1 R, and this is R. Now all these are how many? They are in series. This n minus 1 are in series. These are n resistors are in series. So what is the effective resistance? If I told you that if n resistors are in series of equal values, then effective is only NR. Here n minus 1 resistors are in series. The effective resistance is n minus 1 R. Therefore, this becomes, this is n minus 1 R in parallel with R. This is A and this is B. N minus 1 R parallel with R. Then what is the effective now? Now, if 1 by R parallel is equals to 1 by R plus 1 by R1 plus 1 by R2. This implies RP is equals to R1 R2 by R1 plus R2, we know, we discussed. Therefore, what is the R effective now? R effective is equals to n minus 1 into R, n minus 1 R into R by n minus 1 R plus R. That is equals to n minus 1 into R square by n minus 1 plus 1 into R. This two gets cancelled, is equals to R also gets cancelled. N minus 1 into R by N, N minus 1 into R by N. This is for a polygon. I think you understood. So, if you take 8 resistors, 7 resistors, these 7 resistors are in series. The combination of 7 resistors is 7R. 7R is in parallel with R. These are all 7R. These are all 7R. 7R. These 7 are in parallel with R. Similarly, N resistors. If you take 8 resistors, 7 resistors are in series. Therefore, if you take n resistors, n minus 1 resistors are in series. That effect will be in parallel with the remaining resistor R. Therefore, n minus 1. This here n minus 1 equal resistors. Effective is R plus R plus R plus also n minus 1. Therefore, n minus 1 R by in parallel with R. Effective is R1 R2 by R1 plus R2. That becomes n minus 1 into R by N. Now the problem is given, now this is a small change in the problem. If a uniform wire of resistance R small change here. If a uniform wire of resistance R, if a uniform wire of resistance R is shaped in the form of a polygon. Resistance R, if a uniform wire of resistance R, if a uniform wire of resistance R is shaped in the shape of a polygon, then resistance between any two adjacent corners. This is another mode. Here we taken R. Now the resistance of all this is nothing but R. How many? Divided into n parts. Therefore, if this is a wire of resistance R, it is divided into n equal parts. Therefore, resistance of each part is R by n, R by n, R by n, R by n. Resistance of each part is R by n. Therefore, here, how to do this one? Therefore, a uniform wire resistance R is shaped in the form of a polygon. Again, polygon. Sorry, whole resistance is R. Whole resistance is R. Therefore, resistance of each part is R by n. It is divided n parts. No, R by n, 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 R by n. Again, this take it as A and B. Now, what is the resistance between the remaining two adjacent corners? Again, here in this previous case, the resistance is R each one and divides into n parts. Now, this is total resistance is R. There, what happens? Each resistance is R by n. Now, here again same procedure, R by n, so on so forth to R by n. This is R by n in parallel with again R by n. From this is A, this is B. From A to B, how many will be? If this is n, no, total n, no, this will be n minus 1. Therefore, n minus 1 number of R by n resistors. R by n resistors are in series. What is the effective one? Effective is equals to n minus 1 into R by n. If 2 are there, 2 into R by n. 1 is there, 1 into R by n. 5 are there, 5 into R by n. Therefore, effective is n minus 1 into R by n. Therefore, this is equivalent to. So, this is equivalent to n minus 1 R by n in parallel with R by n. This is A, this is B in parallel with R by n. Now, this is all series of n minus 1 number of resistors, each of value R by n. Therefore, the effective is n minus 1 into R by n. Therefore, this is parallel with remaining one, R by n. Therefore, n minus 1 R by n in parallel with R by n is the R net. Therefore, R net is equals to n minus 1 R by n parallel with R by n. What is R1 R2 by R1 plus R2? R1 R2 by R1 is n minus 1 R by n. R1 R2 by R1 R2 by R1 plus R2. N minus 1 R by n plus R by n. This becomes n minus 1 R square by n square into n minus 1. R will take common plus 1. N minus 1 plus 1 into R by n. 1 gets cancelled and n also gets cancelled. R gets cancelled. That's equals to n minus 1 into R by n square. N minus 1 into R by n square. Previous case, each of resistance are connected in the shape of a n-sided polygon. Then the value of respective resistance is between the adjacent corners is n minus 1 into R by n. But now here total resistance of the wire is R. That is divided into n equal parts. Therefore, each side has a resistance of R by n. Therefore, the effect will be calculated like this. This is one more difference. Next one you may come across this one regularly also. Third one, find equivalent resistance. Find equivalent resistance between A and B. Now, whole circuit is like this. This is infinity, up to infinite. Each of value 1 ohm, 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 and so on and so forth. Okay. How to find this? This is A and B. This is A, this is B. Okay. Now how to find this one? If you observe the circuit, this is going to be infinity. This is going to be infinite circuit. Therefore, we don't have the resistance. Let the effective resistance between A and B is. Let the effective resistance between A and B is X. Now we take this resistance as this is as X we have taken now. Now if you just remove one, neglect this one, take circuit from this P and Q, take it as P and Q here. Now if you neglect this one, for example neglect this one, consider circuit from P to Q. Will you find any difference between the circuit from A to B to infinity and PQ to infinity? Because infinity minus one part is also infinity, infinity plus one part is also infinity. Therefore we find no difference when we remove a single part from infinite series circuit. Therefore, the effective resistance taken as X, the effective resistance between P and Q is also equals to X, because the effective resistance from A to B is X we have taken. Now just we have removed one part out of infinite number of terms, so we have removed only one term, one circuit. Then the effective resistance will not change, will not be affected much. Therefore, the effective resistance, as circuit is infinite, as circuit is running infinite, as the circuit is running infinite, the effective resistance between P and Q is also X, because removing one part from infinity makes no difference. Therefore, the circuit becomes so this is 1, this is 1, this is 1, this is A, this is B, this is X, 1, 1, 1, and this is we are taking as P and Q. This is P and Q. So this also equals to X. The effective resistance of all this also equals to X. Is also equals to X. Therefore, now what is this one now? Now it is simple now. Now X in parallel with 1. X parallel with 1, that is equals to. Effective resistance is 1 into X by 1 plus X. That this becomes, this is A, this is B. This is 1, this is 1 into, therefore 1 into X by X is X by 1 plus X. This is 1. Now again see, A and B. Again see, so this will be, this is A, this is A. This is in between something. This is something. This is A and B. Just I have expanded like this. Expand circuit like this. This is 1. This will be x by 1 plus x. This is 1. Now these three are in series, no? These three are in series. Therefore, R effective is equals to 1 plus x by 1 plus x plus 1. That's equals to the x. We are taking this one as x. Effective, I have told you in the beginning only. Effective resistance of infinite circuit is x. So this should be equals to our x. The effect of A and B. This is all equals to x resistance. This is all equals to x because we are taking considering initial resistance as x for the infinite series. This implies 2 plus x by 1 plus x is equals to x. 2 plus x by 1 plus x is equals to x. 2 plus x by 1 plus x is equal to x. This implies 2 plus 2x plus x. 2 plus 2 plus x is equals to x plus x square. It or not? X plus x square is equals to 2 plus 2. This implies x square plus x minus 3x minus 2 is equal to 0. X square plus x, this is 3x minus 3x minus 2 is equal to 0. Plus x square minus 2x minus 2 is equals to 0. X square minus 2x minus 2 is equal to 0. So by use this by x is equals to minus b plus or minus root over b square minus 4ac by 2a format, quadratic equation. This implies x is equals to minus of minus plus. So plus 2 plus or minus root over b square means 4 minus 4ac 4 into 1 into minus 2 by 2a 2 into 1. This implies x is equals to 2 plus or minus root over how much 4 plus 8 6 12 by 2. This becomes 2 plus or minus 2 root 3 by 2. This implies x is equals to 1 plus or minus root 3. But root 3 is greater than 1. Therefore, resistance is not negative. As resistance is not negative, as R is not negative, therefore resistance R is equals to 1 plus root 3. That is 1.76. Therefore, 2. Is the value of resistance for this infinite network. This way we have to calculate this one. Okay. Now, so far we have seen number of models in calculating resistance. Now let us see what is power. Let us see what is power P. Now the power P, as you know well in the first year, that it is nothing but work by time. Power is equals to work by time, W by T. But the work done is stored in the form of energy. That also is taken as energy by time. Energy by time also. Energy by time also. Power is rate of doing work. Rate of doing work is called as power. Unit of power is equals to work done energy in joules. Joules per second or watt. Joules per second or watt. Now again I think you know heard the term horsepower. Horsepower. Horsepower is equals to 746 watts. 1 horsepower is equals to 1 HP. In motors you will see this one generally. In motors you will see horsepower. 1 horsepower is equal to 746 watts. Now how to define power? The work done in 1 second. If T is equals to 1 second, then P is equals to W joules. W joules by second. That is equals to 1 joule by second. That is equals to 1 watt. Work done in 1 second is equals to 1 joule. Then power is said to be 1 watt. Work done in 1 second is equals to 1 joule. Then power is equals to 1 watt. Now, what is kilowatt hour? Kilowatt hour. Kilowatt hour. Power is equals to work by time, or that is equals to energy by time, joules per second or watt. Keep it aside. Now 1 kilowatt hour, 1 kWh, we call it as 1 kWh. That's equals to 1 into kilo means 10 power 3. Watt means joule per second. 1 hour is equals to 60 into 60 seconds. 1 hour is equals to 60 into 60 seconds. Second. That's equals to 1 into 10 power 3 into 3600 into 3600 joules. That's equals to 36 into 10 power 5 joules. Therefore, 1 kilowatt hour is equals to 36 into 10 power 5 joules. 1 kilowatt hour is equals to 36 into 10 power 5 joules. It is the practical unit in the, this is taken as this energy. This energy is taken as, this energy is taken as 1 unit in our power consumption. In our power consumption in domestic purpose, in house, in domestic purpose or house or a shop, whatever it may be. So generally one unit is equals to 1 unit of energy is equals to 1 kilowatt hour. 1 unit is equals to 1 kilowatt hour energy. 1 unit is equals to 1 kilowatt hour energy. 1 kilowatt hour is equals to 1 unit. Okay. Now, how can we calculate the energy consumed in our house? How can we calculate the energy consumed in our house? Let us see, before entering into this one, let us see this next one. Now, if the number of appliances of what is number of units in house? Number of units in house. If number of appliances, of wattage W1, W2, W3, etc. are operated for H1, H2, H3, so on hours, then number of units or energy consumed is therefore energy is equals to W1 H1 plus W2 H2 plus W3 H3 plus so on and so forth, because power is equals to work by time. Work is equals to power into time, watt into hour. Power is equal to work by time. Work is nothing but energy E. Therefore, energy is equals to watt into time. Mentioned here, hours are given, watt into hour. Therefore, energy can be taken as watt into hour. Watt into hour is the energy. Therefore, total energy is equals to W1 H1 plus W2 H2 W3 H3 plus so on and so forth. This implies energy is equals to sigma over WH. Sigma over WH. Energy is equals to sigma over WH. Now, but I said 1 unit is equals to kilowatt hour. This can be taken as sigma over WH by 1000 into 1000 watt hours. This is the unit. This is the unit. This is all unit. This is watt hours. Watt hours. This is unit. This becomes sigma over WH by 1000 kilowatt hour. This gives number of energy is equals to sigma over WH by 1000 into kilowatt hour. This means energy consumed or number of units. Energy or number of units. Number of units or energy. Number of units or energy. This is given by sigma or WH by 1000 kilowatt, because to get kilowatt we multiplied in divided with 1000. Okay. Now, for example, how to calculate the power consumption in our home? How can we define the power consumption in our home? Power in the home. Power in home. or number of units in home. Number of units in home or energy in home, whatever it may be, or energy in home. Let us say 4 bulbs. 4 bulbs of each of wattage, let us say 50 watts, operated for 6 hours per day. 4 bulbs, each of wattage 50 watts, operated for 6 hours per day. And let us take how many fans? We take some number of fans. Let us take 5 fans. 5 fans, each of wattage 60 watts, operated for 6 hours per day. Let us take 4 bulbs operated for 6 hours, each of wattage 50 watts, and 5 fans, each of wattage 60 watts, operated for 6 hours per day. Now, what is the number of units or energy? Number of units or energy per day is, again, E is equals to sigma over WH by 1000 kilowatt hours. Kilowatt hours. Sigma over WH by 1000 kilowatt hours. This implies E is equals to, first one is 4 bulbs, each of wattage 50, total wattage is 4 into 50 watt, total wattage of 4 bulbs, 50 watt, 50 into 4, 200 watts, how many hours? 6 hours, 6 hours per day, by 1000, plus fans, 5 fans, each of wattage 60, 5 into 60, 5 into 60, number of hours are again taken as 6, by 1000. This is per day number of units or energy. Number of units or energy. This becomes E is equals to 4 5s 20 26 1200. 1200 by 1000 plus 30 180 1800. 1800 by 1000 units per day. Per day units or energy. This is equals to 3000 by 1000 units per day. That is equals to 3 units per day. Now for month, how many units consumed? For month, number of units are 3 into 30. 90 units were consumed for month. Now what is your power bill? So if each unit costs 3 rupees, each unit is 3 rupees. If unit costs 3 rupees, then power bill is, then bill is equals to 90 into 3, 270 rupees. 270 rupees is the power bill. The taxes, extra, that is different case. It is not related to our physics. Therefore, it is how to calculate the number of. You take the number of fans, number of bulbs into daily consumption hours into their wattage by 1000. Similarly, take AC, fridge, mixie. All this comes into the play. This is something about power. Now, next we discuss about next class we discuss about EMF and cells. Thank you.